So in this video, we're going to talk about adding and subtracting rational expressions. So this is going to mirror what we do when we add and subtract fractions. So if you recall, if we're taking 2/3 minus a half, we have to get common denominators. And so our common denominator for thirds and halves will be 6. So then what we have to do is make both of those denominators be the same, that is be 6, and the way we do that is by multiplying top and bottom by the same thing. And so we convert the 2/3 into 4/6 and the 1/2 into 3/6. Once we get our common denominator, we just subtract the numerators and keep that same denominator, and so we would get a 1/6. So the same idea holds when we make our fractions more complicated, that is, we make them rational expressions, where now their numerators and denominators may actually be polynomials, not just numbers. So in the first example here, it's kind of easy because we already have a common denominator. So we just go ahead and add their numerators, and we keep that same denominator. Now at the end, we're looking to reduce and cancel if we can, but in this case, nothing does simplify, and so that is the answer. If we have subtraction, sometimes this can be a little bit confusing too. So let's look at something like 2x plus 1 over x plus 3, and we're going to subtract. I'm going to try to be careful and write that subtraction symbol right on the same level as that line that indicates the fraction, the fraction bar, or it's actually called the vinculum. Now, when we do this minus sign right here acts like a -1, so it has to distribute over what follows it. So we already have the common denominator of x plus 3 here. We don't have to do anything more yet, but we then just distribute the -1, and that is going to make the numerator be a -1 plus x, and then we combine like terms, and so we'll get 3x over the x plus 3, and that's as much as we can do. So that's going to be our answer. Now, sometimes we kind of talked about this in the context of reducing earlier, but if we have something like 3 over x minus 2 plus 5 over 2 minus x, at first glance we might think that, oh shoot, we're going to have a common denominator of x minus 2 and 2 minus x both. But if you remember, we can change one of these denominators to the other just by multiplying by -1. So I'm going to change the 2 minus x into an x minus 2, and the way I'm going to do that is by multiplying by 1, that is by -1 over -1. And so that will leave the first fraction as it is, but it will change the second one to a -5 in the numerator, and distributing that -1 over the denominator will make it be the same denominator that we had in the first fraction. Now we have our common denominator, and so we can just go ahead and combine the 3 and the -5 and call that a -2 over x minus 2. So that's the basics, and then after that it just gets more complicated depending on what our denominators are going to look like. So let's see where we're headed here. Suppose we have a 1 over x squared minus x minus 2 and a minus x over x squared minus 5x plus 6. So we are going to start, as it seems like we do on everything in this chapter, we start by factoring those denominators so we can see what those look like and how we're going to decide what is our common denominator. So the x squared minus x minus 2, using your box and diamond or guess and check, or however you do that, we should come up with an x minus 2 and an x plus 1. On the second fraction, in a similar way, we're going to factor that x squared minus 5x plus 6 to be an x minus 2 and an x minus 3. So now as we look at that, we're looking for a common denominator. So they share an x minus 2, so our common denominator is going to definitely have to have an x minus 2 in it, but only one x minus 2. We also have to have an x plus 1 from the denominator of that first fraction, so we're going to have an x plus 1, and likewise we're going to need an x minus 3 as a contribution from that second fraction. So in order to get that common denominator, we're going to have to multiply top and bottom by what the denominator is lacking. So the first fraction does not have the x minus 3, and so I'm going to have to multiply top and bottom by x minus 3. The second fraction does not have an x plus 1, so I'm going to have to multiply top and bottom by x plus 1. So when we do that, we're going to get in the numerator, the x minus 3 times 1 is going to be just an x minus 3. I'm going to attach that negative to that x and distribute that. So that's going to look like a minus x squared and then a minus x. So we try to simplify and see if anything is going to factor and cancel. But in this case, we're going to get just the negative x squared. The x's are going to drop out. We're going to get a minus 3, and that is not going to factor. And so we're not going to be able to cancel anything else with our denominator. And so that is going to be the end of the story. That is just going to be our answer to that problem. Let's try a couple more examples. So I'm going to get to a new screen. And let's do here, let's try, I'm going to go a negative 1 over x plus 2 over x squared plus 1, and then a plus 1 over x to the third plus x. So now we have three different terms there, and so we're going to have to factor their denominators and decide on a common denominator for all three of those fractions. Well, the x squared plus 1 doesn't factor. It's prime. The x cubed plus x has a greatest common factor of x, and so if I factor that out, we're going to get an x times x squared plus 1. So as we look at those three denominators, to make them all be the same, what we're going to need is an x and an x squared plus 1, both of those. So the first fraction, the negative 1 over x, doesn't have the x squared plus 1, so we're going to have to multiply top and bottom by x squared plus 1 to create that. The second fraction doesn't have an x, so we're going to multiply top and bottom by x to create that denominator. And the third one's okay as it is, so it's just going to stand as it is. So when we take that negative 1 and distribute it, we're going to get a negative x squared minus 1. We're going to get a plus 2x from the second term and a plus 1 from that third fraction. We'll combine like terms, and we'll see that the ones are going to kill each other off. So I'm going to write the positive term first. It's going to be a 2x and then a minus x squared all over x times x squared plus 1. Now, always at the end, what you want to look for is, can we factor and cancel anything? And in this case, we can. So if you look at that numerator, it actually has a common factor of x. And if we pull that out, that's going to leave behind a 2 minus x. And so that can, in fact, cancel with the x in the denominator, which is going to make our final answer then be 2 minus x over x squared plus 1. Let's look at one more example that is kind of a different kind of looking problem, but is really still going to be an add and subtracting rational expressions. It may not look like it initially. So we're going to get x squared times x squared plus 1 all to the negative 5 power minus the quantity x squared plus 1 to the negative 4 power. So what we want to be able to see here is that these negative exponents are going to move the things in parentheses into the denominator, but not affect the things that aren't taken to that power. So that first term is actually going to become the fraction. The x squared will stay in the numerator, and the x squared plus 1 is going to move into the denominator, and that will then become a positive 5 power. In a similar way, the second term, that negative 1, is going to stay in the numerator. I already have the minus sign there, so I'll just leave that as a 1 over, and then that's going to be an x squared plus 1 quantity to the fourth in the denominator. Now it's looking more like what we've been doing, these rational expressions, these things that look like complicated fractions. So as you look at those denominators, they both have, the second one has x squared plus 1 to the fourth. The first one has an x squared plus 1 to the fifth. So we're going to take that x squared plus 1 to the fifth. That's going to be our common denominator. And that means that the second fraction needs one more x squared plus 1 to boost that x squared plus 1 to the fourth into a fifth power. So that means that when we combine those, that first x squared from the first fraction is just going to stay x squared. The minus sign that comes with the negative 1 will distribute and make that be a minus x squared minus 1. And that then, when we combine like terms, those x squareds will drop out, and we're going to get just a negative 1 over the quantity x squared plus 1 to the fifth. And that's going to be our answer. All right. These are going to be a little bit tougher, so make sure you're checking your answers and figuring stuff out as you try this worksheet on adding and subtracting fractions.